Hello everyone and welcome to Golang Cafe. Today we're going to talk about Go maps. Go maps are a very powerful data structure. You will see them in a lot of places when working with Go, and you will also see in the Go standard library as well. And Go maps are also known in other programming languages as hash maps or hash tables or dictionaries. So are a very fundamental data structure that you will study if you go into a computer science background, and very powerful. So it's very important that you master them and you learn them how to use them. So today we're gonna go through a couple of examples on how we can use the map, how the map works on high level, how you can store elements into the map and retrieve and delete elements from the map. And we'll see just a couple of examples so you will be familiar with the data type. So Go maps are a data type of the Go runtime, and you can define Go maps by using the map keyword. So here I've just created a file, an example file, and you can use the map keyword to define maps. And when you define maps, you need to specify a key type for the map and a value type for the map. As you would do in probably other programming languages as well, you can store items into the map by using a key, which is used to uniquely identify and set or get items from the map, and each key has a value associated with it. So the important characteristics of the map is that you can access almost in constant time, or at least most of the cases it's constant time, very quickly. You can access values into the map by just using a key, like you would do with arrays, for example. So with arrays, what you have is, like, let's say you have an array with the 4 elements. In memory, what happens is that the array has some values in there, and the indexes of the array are going to be integer indexes, which start from 0, and they will go through the length of the array. So this is how an array is represented in memory. Why is this relevant for the map? Well, it's relevant because it's very similar in a way, and it will allow us to see what's the main difference between arrays and maps. So the main difference is that when arrays are stored in memory with values that can be integers or string or any type, and indexes can only be integers. In map, the indexes can also be other types. So in the map, for example, you have the same values. So you have 1, 2, 3, and 4, and then you can specify that you have the keys indexes, which in the map you call keys. And the keys in the map can be any type, almost any type in Go, almost any type, not all types. But in the array, you can only use the integer type. In the map, the keys, which are the equivalent of indexes in array, well, you can use any type. You can use, for example, string. So here you would have each key corresponding to an item in the array, for example, as you can see. So in memory, this will look something like this. You will see that you have a set of keys, and for each key you have an underlying value associated with the key, as well as how you would do that with the array. But the only difference is that in the array you cannot use a string, so you cannot use other types. You can only use integers. With a map you can use strings as well. So this is one of the very interesting characteristics, and the keys are unique. So you will never see in a map, you never see duplicated keys. So you never see something like this. You will see duplicated keys in the map. You always have unique keys. So how do we define a map? Well, the first thing we need to know is that the key type that we can use, we've seen before we used a string, so we can use almost any type, but there are sometimes in the Go runtime that we cannot use. Which type we cannot use? We cannot use types that cannot be compared, so they're not comparable types. And those types are the function keyword, the channel keyword, sorry, the slice keyword and the map keyword, the map types basically. So those are the three types that cannot be compared. So the func and the slice and the map, they cannot be compared. And if you think about it, those are reference types. So the map cannot really be compared to another map, and the slice cannot be really compared to another map or to another slice. So those are some of the types that you can actually use as a key type. Other than that, you can use any other type. So you can use a map defined with a key of strings, or a map defined with a key of integers or floats, float 64, or you can use Boolean, or you can use a struct as well, which we will see later. So how do we declare a map? So once we know that we can only use certain types for the key, and we use any type as a value type, we can start to declare our map. Well, how do we do that? There are a couple of ways. The first way is to use the make keyword. So you can use the make keyword. You have your map. We choose to use a string, and as a value we can you can use a slice of strings. So remember, we cannot use a slice as a key. So if we were to use the slice here, we couldn't do that. But as a value type, you can use any type. You can also use a slice of strings. So we can use a map itself as well. We can use any type really. So this is how you declare a map, by using the make keyword. Or there is an alternative way, or you can declare a map by just initializing the map with a default value. So here we just use the brackets, and this is an empty initialization, but if you wanted, you could basically do something on those lines. So and you could specify your values here, and so on. So now let's just use the make keyword. What kind of operations can you do with the map? Well, you can add items to the map, you can get items from the map, and you can delete items from the map. Whenever you add an item, you need to specify a key and a value. So you add an item to the map, you add a key, and you set a key to the map, and the key has a value associated with that, which is what you specify. And then when you get an item from the map, you only know the key. You want to know the value for that key. And when you delete, it's the same. When you delete, you want to delete the value associated with the key in the map. So let's go through an example. How do we do that? We use the map name, we use the square brackets notation, and then we specify the key. So here I want to say I have a key called fruits, and I have a value which is a string slice, and here I can specify the value for that. So I can apple, pear, and peach, and cherry. So this is how we set items, and you can do the same here. So for example, vegs, and here you have the same thing. So this is how you add items into the map. How do you get items from the map? You can get items from the map by just declaring a variable, and then using the same notation, but you just basically use the square brackets, and then you specify from which key you want to get the item from. So you do it like this, and then we attempt to got fruits from map, and here we attempt to print the map. We just do like that, and then the delete of an item from the map. How do you delete an item? Well, we use the delete keyword. So there's a specific keyword for doing that. We specify the map, the variable of the map, and then the key which we want to delete. Now let's see map after delete. So just to recap, we have just instantiated a map that maps a string to a string slice. We have added a couple of elements to the map using a key and a value. So we associate this value of a string slice, which is a set of fruits, to the fruits key set of vex to the vegetable key to the vex key. We print the map, so here we should see two elements, at least two keys, each of which will have a slice of string slice. Then we attempt to get an item from the map, and then we attempt to delete an item from the map. So let's go here, and we can just run this example. So the first thing, we just print the map. We got fruits from map, attempt to read the fruits as you see, and then we print again the map without the fruits because we deleted the fruits from the map. So if you want to know, if you want to check the documentation of the keywords we've just used, so we have the make keyword, which is in the built-in doc package. The make keyword can be used, and it's usually used when initializing slices, when initializing maps or channels. We're not used for the map, and you can also use a size. You can also specify a size for the map. If you know how many elements you're going to have for the map, then it's probably best to use that, because then the map doesn't have to allocate dynamically and change and resize dynamically based on how many items you add into the map. So if you already know how many keys you have in the map, you can specify that by adding a size as a second parameter in the make keyword. And the same goes for the delete keyword. Godoc built-in delete. It is used to delete items from the map, as we have seen, and it will basically attempt to remove the key that you specify as a second parameter from the map, but if the key does not exist, it will not return any error. So this is a gotcha you need to be aware of. The delete doesn't actually return any error, or doesn't panic or returns any error if the key does not exist or if the map is nil. So when is the map nil? This is something that sometimes happen when you first declare the map. You forget to declare the map in this way, or you incorrectly declare the map. And if you, for example, declare the map in this way just by declaring the map but not initializing the map, you will see a couple of issues. So the first issue, obviously here we don't want to initialize it, we just want to declare it. The first issue is that M is now nil. So whenever you attempt to store data into a nil map, you will panic. So the program will panic, as you see. But if you try to delete, or if you try to get an item from a nil map, you won't get any error. As you see, it's just returning an empty map, as you see here. So this is something you need to bear in mind. Whenever the map is nil, I mean, there is no point of using a nil map because it's a nil value. But this is a behavior of the runtime. So if the map is nil and you attempt to read the value from the map, then nothing happens. You just get an empty value, zero value. If you attempt to delete from a nil map as well, nothing happens. So those are some of the things that you need to be aware of. If you attempt to write into a nil map, obviously this will panic. So always remember to declare the map, either by using the make keyword or either by using the initialization, as we've seen before. Okay. So now, one of the things I wanted to go through is checking how many elements are there in the map. So you can use the len keyword to check that. This will print the number of elements. And whenever you want to loop through the map, you can use the range keyword in a for loop. And this will allow you to check all elements in the map. So here we deleted the fruits keyword, so we got just one element with the vegetables. So let's just now comment. we will see a couple of elements, as you see here. So another thing to remember about the range keyword in the map is that whenever you range over a map, the order in which the map is being iterated over is not defined. So here you can see the same program we're running. The first time you get the vegs and then fruits, and then the second time we're running you get fruits and then vegs. So it's not defined whether the order is going to be a specified order. It's very probably going to change. As you see here now, it changed again. So this is something you need to be aware in mind. Whenever you range over a map, the order is not guaranteed. So it is not like slices. If you range over a slice using the range keyword, then the order is guaranteed. So if you want to keep to maintain the order, to have a deterministic order, then you should use a slice instead, or at least range over the slice in that way using the range keyword and not a map, or not range over a map. Okay, so another example I wanted to go through is the usage of a struct whenever you want to use a map. So let's go through the aggregation key struct. So let's say that we want to define, we want to build a custom in-memory database. Okay, that's our objective, and we are trying to aggregate weather data, and this weather data is aggregated by date and sensor type. So you will have something like, this is the data that we receive from our sensor, like date, and then it's like the date, and then sensor type. This is gonna be like temperature, and then value. It's gonna be 20 degrees and 12 or something. And you can think of that as like a set of items in there. And here you will have probably different sensor types, humidity as well. So you got the gist. They probably have different values and different dates as well. So you can use a struct to define a key for your map and then store that value in your map. So let's just weather data. We can define a weather data map, which is aggregation key, and then we have float 64. Weather data is a key, date is like, and sensor type. And then we set the value. And then we can do the same for example, other sensor. And so on and so forth. So as you can see, it is very powerful. The way you can define keys in the map is very powerful, because you can have any type of struct here, and this struct will be used as a key in the map, and so you can do any type of, in this case it's a kind of an aggregation. So trying to build like an in-memory database where we store this data here, and we do a group by, so an aggregation by date and sensor type, and here you will have all those values in there. So let's see how this plays out whenever we attempt to run it. Obviously we will need to aggregation key, Okay. As you can see here, we just seen the map result, the content of the map using having humidity, the date, and the value, and temperature and the value, as we've seen in our program. So those are just some of the examples how you can use the map and how the map is very powerful. Obviously, each time you access values from the map, it is very quick to access the value. Is a best case scenario is constant time, and you can use any type of key as we've seen. Just a few exceptions like the func that slides on the map, but otherwise you can use a struct, the string, the integers. So these are the main characteristics of the map and how you can use the map. Hope you liked, and see you in the next one. Thanks.